Hi, myself Veena, physics lecturer, Vishwamanava Composite PU College, Sibara, Chitradurga. Today, in this session, I am going to discuss about the continuation part of the magnetism and matter. In this video, I am going to discuss, see, what are the contents including in this video. The first one is analog between magnetism and electrostatics. That is a comparison between the magnetism and electrostatics. So the next, Gauss law in magnetism and Earth's magnetism. The next, source of Earth's magnetism, general features of Earth's magnetic field, and finally, important terms used in geomagnetism. Now, let us see one by one. What is the comparison between the magnetism and electrostatics? Now, first chapter electrostatics ಬಗ್ಗೆ study ಮಾಡಿದ್ವಿ, and in the fourth chapter we have studied about the magnetism. So, what is the similarity between the magnetism and electrostatics? ಎಲೆಕ್ಟ್ರೋಸ್ಟ್ಯಾಟಿಕ್ಸಿಗೂ ಮ್ಯಾಗ್ನೆಟಿಸಮ್ಗೂ ಕೆಲವೊಂದು ಸಿಮಿಲಾರಿಟೀಸ್, ಆ ಕಂಪ್ಯಾರಿಸನ್ನ ನೋಡ್ತಾ ಹೋಗೋಣ. ಸೊ ಸಿ, magnetism and electrostatics have basically matching relations. ಅಂದರೆ ಎಲೆಕ್ಟ್ರಿಸಿಟಿಗೂ ಮತ್ತು ಮ್ಯಾಗ್ನೆಟಿಸಮ್ಗೂ ಒಂದಕ್ಕೊಂದು ರಿಲೇಷನ್ ಇದೆ. ಇನ್ ಮೆನಿ ರಿಲೇಷನ್ಸ್ ಫಾರ್ ಎಲೆಕ್ಟ್ರೋಸ್ಟ್ಯಾಟಿಕ್ಸ್, if the electric field E is replaced with the magnetic field and 1 by 4 pi epsilon naught is replaced with the mu naught by 4 pi. So see, in the electric field is represented by E and the magnetic field is represented by B in the many cases. So most of the cases ಅಲ್ಲಿ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ನ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ಬೇಕಾದ್ರೆ ನಾವು ಇ ಅಂತ ತೊಗೊಳ್ತೀವಿ, ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ನ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ಬೇಕಾದ್ರೆ ಬಿ ಅಂತ ತೊಗೊಳ್ತೀವಿ. ಸೊ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡಲ್ಲಿ 1/4 π ಎಪ್ಸಗಾನ್ನ ಇಟ್ಟಿದ್ರೆ ದಟ್ 1/4 π ಎಪ್ಸಗಾನ್ನು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡಲ್ಲಿ μ0/4 π ಅಂತ ರೆಪ್ರೆಸೆಂಟ್ ಆಗುತ್ತೆ. ದಟ್ ಈಸ್ μ0/4 π. ಸೊ ಸಿ, epsilon naught is the permittivity of free space and mu naught is the permeability of free space. So now let's see what is the comparison between those two. See, electric field in a region is represented by the imaginary lines called electric lines of force. So ನಾವು ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡಿನ ಒಂದು ಇಮ್ಯಾಜಿನರಿ ಲೈನ್ಸಿಂದ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತೀವಿ. ದೋಸ್ ಇಮ್ಯಾಜಿನರಿ ಲೈನ್ಸ್ ಆರ್ ಕಾಲ್ಡ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಲೈನ್ಸ್ ಆಫ್ ಫೋರ್ಸ್. ಸೊ ಇನ್ ದ ಕೇಸ್ ಆಫ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್, ಸೇಮ್ ಆಸ್ ಇಟ್ ಇಸ್ ದ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್. ಸೊ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡಿನ ಹೆಂಗೆ ಇಮ್ಯಾಜಿನರಿ ಲೈನ್ಸಿಂದ ಡ್ರಾ ಮಾಡ್ತೀವೋ, ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತೀವೋ, ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡನ್ನು ಕೂಡ ನಾವು ಇಮ್ಯಾಜಿನರಿ ಲೈನ್ಸಿಂದ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತೀವಿ. ಸಿ, the magnetic field in a region is represented by imaginary lines called magnetic field lines. Electric field is represented by electric field lines. Same as it is in the magnetic field, the magnetic field is represented by the magnetic field lines. So now let us see the next one, the electric flux. So now what is meant by electric flux? See, the total number of electric lines of force passing normally through that surface area is called electric flux. That means, see, this is a closed surface area. In this surface area, the number of electric lines of force andre means electric field lines ಎಷ್ಟು ನಾರ್ಮಲ್ ಆಗಿ ಪಾಸ್ ಆಗಿರುತ್ತೆ ಆ ಸರ್ಫೇಸ್ ಏರಿಯಾದಲ್ಲಿ, ಅದನ್ನು ನಾವು ಎಲೆಕ್ಟ್ರಿಕ್ ಫ್ಲಕ್ಸ್ ಅಂತ ಕರಿತೀವಿ. That electric flux is given by pi is equal to EDS cos theta, where pi represents the flux, E represents the electric field, ds represents the closed surface area. So see, in the case of magnetic flux, same also. Magnetic flux means number of magnetic lines passing through a given closed surface. Electric field ಅಲ್ಲಿ electric field lines, ಆ ನಂಬರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸು ಆ ಸರ್ಫೇಸ್ ಏರಿಯಾದಲ್ಲಿ ಎಷ್ಟು ಪಾಸ್ ಆಗಿರುತ್ತೋ ಅವನ್ನ ಎಲೆಕ್ಟ್ರಿಕ್ ಫ್ಲಕ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ ಇನ್ ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡಲ್ಲಿ ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಲೈನ್ಸ್ ಎಷ್ಟು ಪಾಸ್ ಆಗಿರುತ್ತೋ, ದ ನಂಬರ್ ಆಫ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ field lines passing through the closed surface. That is called a magnetic flux. That magnetic flux is given by pi is equal to BA cos theta. Here B represents the magnetic field, A represents the area. So electric flux is given by pi is equal to EDS cos theta, and magnetic flux is given by pi is equal to BA cos theta. So next see the third comparison between the electric field and magnetic field. So see, electric dipole moment. So now what is meant by dipole moment? It is the product of any one of the charge and the distance between the two charges. So see, this is considered as a positive charge. Here it is taken as a negative charge, and so here we can electric dipole means it is a product of any one charge. So we can take the positive charge or a negative charge. Positive charge ಆದ್ರೂ ತಗೋಬಹುದು, negative charge ಆದ್ರೂ ತಗೋಬಹುದು. And distance between the two charges. See, 2a is the distance between the two charges. And a dipole moment is given by, in the case of electric field ಅಲ್ಲಿ P is equal to Q into 2a, where P represents the dipole moment. P represents the dipole moment and Q represents the charge, and 2a represents the distance between the two charges. In the case of magnetic dipole moment, so dipole moment is the product of any one pole strength and the distance between the two poles. Here the pole strength is represented by Qm, and the distance between the two poles is given by 2L. Oh, the magnetic dipole moment is M is equal to Qm into 2L. So electric dipole is P is equal to Q into 2A. Same as it is in the case of magnetic field. Magnetic dipole moment is M is equal to Qm into 2L. So next, see the next comparison. Electric field at a point at a distance r from the point charge Q. So see here, this is the point charge. So the point P, which is at a distance r, this is the point P. So the electric field at a point at a distance r from the point charge Q is. So ಈ ಪಾಯಿಂಟ್ ಪಿ ಎಲ್ಲಿರುವಂತಹ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ನಾವು ಇಟ್ ಈಸ್ ಗಿವನ್ ಬೈ ಇ ಇಸ್ ಈಕ್ವಲ್ ಟು 1/4 pi epsilon naught q divided by r square. Here q represents the charge, r is the distance between the charge and the point p. That is electric field is given by e is equal to 1/4 pi epsilon naught q divided by r square. So see, in the case of magnetic field at a point at a distance r from the magnetic pole. So this is the magnet having the north and the south pole. The point P, which is at a distance r from the any one pole. So one magnet ತಗೊಂಡಿದ್ವಿ, it has the pole. The point P ನ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ದೀವಿ. ಆ ಪಾಯಿಂಟ್ P r ಡಿಸ್ಟೆನ್ಸ್ ಅಲ್ಲಿದೆ. So now we have to give the expression for the magnetic field at point P. So we have already derived the equation, that is P is equal to mu naught by 4 pi Qm divided by r square, where Qm represents the pole strength, r is the distance between the any one pole and the point P. I'm already told the in the electric field we have to use the 1/4 pi epsilon naught. That 1/4 pi epsilon naught in the magnetic field is replaced by mu naught by 4 pi. Here epsilon naught represents the permittivity, mu naught represents the permeability of free space. So see the next comparison, fifth one, torque on a electric dipole of dipole moment P placed in a electric field E at an angle theta with the field is. So see, ನಾವು ಒಂದು ಎಲೆಕ್ಟ್ರಿಕ್ ಡೈಪೋಲ್ನ ಎಕ್ಸ್ಟರ್ನಲ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಒಳಗಡೆ ಪ್ಲೇಸ್ ಮಾಡ್ತೀವಿ. ಸೊ ಎಕ್ಸ್ಟರ್ನಲ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಒಳಗಡೆ ಪ್ಲೇಸ್ ಮಾಡಿದಾಗ ಇಟ್ ಎಕ್ಸ್ಪೀರಿಯನ್ಸಸ್ ದ ಟಾರ್ಕ್. ದಟ್ ಟಾರ್ಕ್ ಈಸ್ ಗಿವನ್ ಬೈ tau is equal to P cross E. It is a cross product of P into E. So P represents the dipole moment and E represents the electric field. So it is given by tau is equal to PE sin theta. So in the case of magnetic field, the torque on a magnetic dipole having the dipole moment M is placed in the external magnetic field. ಸೊ ನಾವು ಒಂದು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಡೈಪೋಲ್ನ ತೊಗೊಂಡಿದ್ದೀವಿ. ದಟ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಡೈಪೋಲ್ ಈಸ್ ಪ್ಲೇಸ್ಡ್ ಇನ್ ದ ಎಕ್ಸ್ಟರ್ನಲ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಬಿ. ಸೊ ಎಕ್ಸ್ಟರ್ನಲ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡಲ್ಲಿ ಇರೋದ್ರಿಂದ ಇಟ್ ಎಕ್ಸ್ಪೀರಿಯನ್ಸಸ್ ದ ಟಾರ್ಕ್. ದಟ್ ಟಾರ್ಕ್ ಈಸ್ ಗಿವನ್ ಬೈ tau is equal to m cross b. That is a cross product of m into b. Tau is equal to mb sin theta, where m represents the dipole moment and B represents the magnetic field. So in the case of electric field, it is a P cross E. In the case of magnetic field, it is a M cross B. So now next, see the next comparison. The electric field at a point on the axial line of a short electric dipole. Electric dipole. So positive, negative separated by a small distance. So the electric field along the axis of the dipole. Axial line means it is along the axial line of the dipole that is given by. So we have already derived the equation in the first chapter, that is E is equal to 1 by 4 pi epsilon naught 2p divided by r cube, where p is the dipole moment. So in the case of magnetic field, the magnetic field at a point on the axial line of a short magnetic dipole, that is means along the axis of the dipole. So magnet in a axis. So that is given by B is equal to mu naught by 4 pi 2m divided by r cube. So here m represents the dipole moment. So see here also 1 by 4 pi epsilon naught is replaced by mu naught by 4 pi and E is replaced by B. Next, see the next comparison. Electric field at a point on the equatorial line of short dipole. Equatorial means perpendicular bisector. So this is the dipole, this is the equatorial line, that is given by E is equal to 1 by 4 pi epsilon naught P divided by r cube. Now P is the dipole moment, R is the distance. So in the case of magnetic field at a point on the equatorial line of short magnetic dipole, that is given by B is equal to mu naught by 4 pi m divided by r cube, where m is the dipole moment. So see here also in this case 1 by 4 pi epsilon naught is replaced by mu naught by 4 pi. E is replaced by B. So this is about the comparison between the electric field and magnetic field. So next, see Gauss law in magnetism. So now already first chapter study the Gauss law in electrostatics. So same as it is the Gauss law in magnetism. So Gauss law in magnetism states that the net magnetic flux through any closed surface is always zero. So see the magnetic flux. ನಮಗೆ ಗೊತ್ತು magnetic flux ಅಂತ. So see the number of magnetic field lines passing through a given closed surface. So see this is a closed surface. So the number of magnetic field lines passing through that closed surface. So the net magnetic flux through any closed surface is always zero. So that means this implies that the number of magnetic field lines leaving any closed surface is equal to the number of magnetic field lines entering it. ಅಂದರೆ ಎಷ್ಟು ನಂಬರ್ ಆಫ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಎಂಟರ್ ಆಗ್ತಾವೋ ಅಷ್ಟು ನಂಬರ್ ಆಫ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸು ಇದರಿಂದ ಹೊರಗಡೆ ಬರ್ತವೆ. ಆಸ್ ಅ ನೆಟ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫ್ಲಕ್ಸ್ ಥ್ರೂ ಎನಿ ಕ್ಲೋಸ್ಡ್ ಸರ್ಫೇಸ್ ಈಸ್ 0. See here, this represents the figure. In the figure, consider a closed surface S in a uniform magnetic field. So this is the closed surface. That closed surface na ನಾವು ಯೂನಿಫಾರ್ಮ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಒಳಗಡೆ ಪ್ಲೇಸ್ ಮಾಡ್ತೀವಿ. So let delta S be a small area element of this surface with n cap along its normal. So see, this is the closed surface. ಆ ಕ್ಲೋಸ್ಡ್ ಸರ್ಫೇಸ್ ಒಳಗಡೆ ಒಂದು ಸ್ಮಾಲ್ ಏರಿಯಾ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ದೀವಿ. ಆ ಸ್ಮಾಲ್ ಏರಿಯಾನ ಒಂದು ಏರಿಯಾ ಎಲಿಮೆಂಟ್ ಅಂತ ಕರಿತೀವಿ. ಏರಿಯಾ ಎಲಿಮೆಂಟ್. ಸೊ ದಿಸ್ ಇಸ್ ದ ನಾರ್ಮಲ್. Then the magnetic flux through this area element is, that is, delta pi b is equal to b dot delta s. Now magnetic flux ನೋಡಿದ್ವಿ, b dot delta s, where b is the magnetic field, delta is the area element, small area element. Now see, the total magnetic flux through the closed surface is the sum of the magnetic flux through all area elements on the closed surface. So ನಮಗೆ ಗೊತ್ತು, ಸೊ ಏರಿಯಾ ಎಲಿಮೆಂಟಿಂದ ಇರೋಂಥ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫ್ಲಕ್ಸ್ ಇಸ್, ದಟ್ ಈಸ್ ಡೆಲ್ಟಾ ಪೈ ಬಿ ಇಸ್ ಈಕ್ವಲ್ ಟು ಬಿ ಡಾಟ್ ಡೆಲ್ಟಾ ಎಸ್. ಸೊ ಸಿ ಹಿಯರ್, this closed surface contains a large number of area elements. ನಮಗೆ ಬೇಕಾಗಿರೋದು ದ ಟೋಟಲ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫ್ಲಕ್ಸ್ ಥ್ರೂ ದ ಕ್ಲೋಸ್ಡ್ ಸರ್ಫೇಸ್. ಸೊ ಆ ಕ್ಲೋಸ್ಡ್ ಸರ್ಫೇಸಿಂದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫ್ಲಕ್ಸ್ ಬೇಕು ಅಂದರೆ ವಿ ಹ್ಯಾವ್ ಟು ಆ್ಯಡ್ ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫ್ಲಕ್ಸ್ ಥ್ರೂ ಆಲ್ ದ ಏರಿಯಾ ಎಲಿಮೆಂಟ್ಸ್. ಸೊ ದಿಸ್ ಸರ್ಫೇಸ್ ಏರಿಯಾ ಕಂಟೈನ್ಸ್ ದ ಲಾರ್ಜ್ ನಂಬರ್ ಆಫ್ ಏರಿಯಾ ಎಲಿಮೆಂಟ್ಸ್. ಸೊ ನಾವು ಸಿ the sum of the magnetic flux through all area elements on the closed surface, that is given by pi b is equal to summation delta pi b is equal to summation b dot delta s. This is the total magnetic flux through this closed surface. Now see, according to Gauss Law in magnetism, that is that the net magnetic flux through the closed surface is 0, that is pi b is equal to 0. Now see, according to Gauss Law in electrostatics, that is the total electric flux across a closed surface in an electric field is given by pi e is equal to summation e dot ds, that is equal to 1 by epsilon naught times the total charge enclosed by that closed surface. So in the case of Gauss law in magnetism, it is always 0, but in the case of Gauss law in electrostatics, it is equal to q divided by epsilon naught. Suppose we have pi e is equal to 0, pi e is equal to 0 only ಯಾವಾಗ if the charge enclosed by the closed surface is 0. That means, so Gauss law in magnetism, the magnetic flux is always 0, but in the case of electrostatics, it is equal to q divided by epsilon naught. So only the pi e is equal to 0 ಯಾವಾಗ when the closed surface is enclosed by the charge. Closed surface is 0. The charge enclosed by the closed surface is 0. That is q is equal to 0. Or the closed surface encloses the electric dipoles. Electric dipoles means positive and negative charge separated by a small distance. A closed surface ಒಳಗಡೆ ಎಲ್ಲ electric dipoles ಇದ್ದರೆ the number of positive charges are equal to number of negative charges. ಸೊ ಏನಾಗುತ್ತೆ, ನ್ಯೂಟ್ರಲ್ ಆಗುತ್ತೆ. Hence the charge is equal to 0. ಚಾರ್ಜ್ ಏನಾಗುತ್ತೆ, 0 ಆಗುತ್ತೆ. ಚಾರ್ಜ್ 0 ಆದಾಗ ದ ಟೋಟಲ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫ್ಲಕ್ಸ್ ಇಸ್ 0. Now see, according to Gauss law in magnetism, B is equal to 0 ನಮಗೆ ಗೊತ್ತು. This implies that the simplest magnetic element is a dipole or a current loop. The magnetic monopoles do not exist. ಏನಪ್ಪ ಹಾಗಾದರೆ, ಚಾರ್ಜ್ ನಮಗೆ ಸಪ್ರೇಟ್ ಸಿಗುತ್ತೆ, ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಆ್ಯಂಡ್ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್. ಬಟ್ ಮ್ಯಾಗ್ನೆಟಿಸಮ್ ಅಲ್ಲಿ, ಮ್ಯಾಗ್ನೆಟಿಕ್ ಡೈಪೋಲ್ ಅಲ್ಲಿ monopoles do not exist. They are always exist in pairs. ನಾರ್ತ್ ಪೋಲ್ ಮತ್ತು ಸೌತ್ ಪೋಲ್ ಯಾವಾಗಲೂ ಕೂಡ ಪೇರಲ್ಲೇ ಎಕ್ಸಿಸ್ಟ್ ಆಗ್ತವೆ. ದೇ ಕೆನಾಟ್ ಬಿ ಸಪರೇಟೆಡ್. ಹ್ಯಾನ್ಸ್ Gauss law in magnetism, it is always zero. This implies that the simplest magnetic element is a dipole or a current loop, that is magnetic monopoles or do not exist. Now see, earth magnetism. So now what is meant by earth magnetism? See, the study of magnetism of earth is known as a geomagnetism or terrestrial magnetism. ಸಿ, ನಾವು ಅರ್ಥಿನ ಮ್ಯಾಗ್ನೆಟಿಸಮ್ ಬಗ್ಗೆ ಸ್ಟಡಿ ಮಾಡೋದಕ್ಕೆ ಜಿಯೋ ಮ್ಯಾಗ್ನೆಟಿಸಮ್ ಅಥವಾ ಟೆರೆಸ್ಟ್ರಿಯಲ್ ಮ್ಯಾಗ್ನೆಟಿಸಮ್ ಅಂತ ಕರಿತೀವಿ. ಸಿ, ಎ ಫ್ರೀಲಿ ಸಸ್ಪೆಂಡೆಡ್ ಮ್ಯಾಗ್ನೆಟ್ ಓರಿಯೆಂಟ್ಸ್ ಇನ್ ದ ಜಿಯೋಗ್ರಫಿಕ್ ನಾರ್ತ್ ಸೌತ್ ಡೈರೆಕ್ಷನ್. ಸೊ ಲಾಸ್ಟ್ ಕ್ಲಾಸಲ್ಲಿ ನೋಡಿದ್ವಿ. ಸೊ ಫ್ರೀಲಿ ಸಸ್ಪೆಂಡೆಡ್ ಮ್ಯಾಗ್ನೆಟ್ ಆಲ್ವೇಸ್ points towards the north-south direction. This indicates that there is a magnetic field around the earth. ಸೊ ಆ ಮ್ಯಾಗ್ನೆಟು ನಾರ್ತ್ ಮತ್ತು ಸೌತ್ ಪೋಲ್ಸಲ್ಲೇ ಪಾಯಿಂಟ್ ಮಾಡೋದು, ಸೌತ್ ಡೈರೆಕ್ಷನ್ನಲ್ಲೇ ಪಾಯಿಂಟ್ ಮಾಡೋದ್ರಿಂದ ದಟ್ ಇಂಡಿಕೇಟ್ಸ್ ದೇರ್ ಈಸ್ ಅ ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಅರೌಂಡ್ ದ ಅರ್ತ್. ದಟ್ ವಾಸ್ ಡಿಸ್ಕ್ರೈಬ್ಡ್ ಬೈ ದಿಸ್ ವಿಲಿಯಂ ಗಿಲ್ಬರ್ಟ್. ಸೊ there is a presence of magnetic field in the earth that was demonstrated by the William Gilbert. So now see, earth magnetism is similar to a bar magnet placed well inside the core of the earth. ಅಂದರೆ ಅರ್ಥಿನ ಮ್ಯಾಗ್ನೆಟಿಸಮು ಬಾರ್ ಮ್ಯಾಗ್ನೆಟಿಗೆ ಸಿಮಿಲರ್ ಆಗಿ. It is found that the strength of Earth's magnetic field varies from place to place on the Earth's surface. That means it is not constant. Earth surface ಮೇಲೆ one place ಇಂದ ಇನ್ನೊಂದು ಪ್ಲೇಸಿಗೆ the strength of magnetic field is varies. So see, the order of the magnetic field strength of the Earth is about generally, it is about 10 to the power of minus 5 Tesla. That is the strength of magnetic field. So now see the sources of Earth's magnetism. So see, according to Brock, Earth's magnetism may be due to the rotation of Earth about its axis. So this is the Earth. This is the axis of rotation of Earth rotates like this. So see, this is because every substance is made of charged particles. Already we know every substance is made up of charged particles such as protons and electron. And substance rotating about an axis is equivalent to circulating currents. We know that the current, what is meant by current? The flow of charges is nothing but a current. Here the charges are rotating in the axis. So that is equivalent to the circulating current. So we know that the flow of current produces the magnetic field in the surrounding space. The flow of current in the conductor produces the magnetic field in the surrounding space. So this is responsible for the Earth's magnetism. This circulating current is responsible for the Earth's magnetism. See, the Earth magnetism is due to the electric currents produced by the convective motion of metallic fluids. That is the motion of the metallic fluids. So the metallic fluid consists of metallic iron and nickel. It consists of iron and nickel. Due to that motion of metallic fluids, the electric current is produced. That electric current produces the magnetic field. So in the outer core of the Earth. So this is all about done in the outer core of the Earth. So this is known as the dynamo effect. That is called the dynamo effect. So next see, the general features of the Earth's magnetic field. What are the general features of the Earth's magnetic field? The magnetic field lines represent the magnetic field of Earth or sea. Here we know that the magnetic field is represented by the field lines. So here the Earth's magnetic field is also represented by the field lines. The Earth's magnetism is assumed due to a huge bore magnet with its axis inclined at an angle of 11.3 degree west of the axis of rotation of the Earth. See in the figure, this is the Earth. So this is the axis of rotation of the Earth, and this is the magnet. See, it inclined at an angle of 11.3 degree with the axis of rotation of the Earth. So now see in the figure. So this is the Earth. This is the axis of rotation of the Earth. This is the axis of the magnet, and this is the magnetic equator. This is the geographic equator. See the south pole of this magnet towards the geographic north. So see, this is the geographic south, this is the geographic north, this is the south pole of magnet, this is the north pole of the magnet. The south pole of this magnet towards the geographic north, it acting towards the geographic north, and its north pole is towards the geographic south, it acting towards the geographic south. Next, see the magnetic field lines due to the earth magnetism are parallel to the earth surface near the magnetic equator and perpendicular to the earth surface near the magnetic poles of earth, as we shown in the figure. The field lines are parallel to the earth's surface where it is near the magnetic equator, and it is perpendicular to the earth's surface near the magnetic poles. Now see, important terms used in geomagnetism. So first one is geographic axis. See, an imaginary line joining the geographic poles of the earth is known as the geographic axis. Now figure all ನೋಡಿದ್ವಿ. So this is the earth, this is the axis of rotation of the earth. The line joining the geographic poles here, this is the geographic poles. The line joining the geographic poles of the earth is known as the geographic axis. And the second one, the magnetic axis. The line joining the magnetic poles of earth is called magnetic axis. See in the figure. So this is the magnetic axis. So this is the north pole of the magnet, this is the south pole of the magnet. See, this magnetic axis does not coincide with the geographic axis. It is inclined at an angle of 11.3 degree with the axis of rotation of the earth. So that is the magnetic axis. So see, the magnetic axis do not coincide with the earth. The magnetic axis makes an angle of about 11.3 degree with the geographic axis. ಆದರೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಆಕ್ಸಿಸ್ ಮತ್ತು geographic axis coincide ಆಗಿರಲ್ಲ. The magnetic axis is inclined at an angle of 11.3. So next see the geographic equator. It is the great circle on the earth perpendicular to the geographic axis. This is the earth, this is the geographic axis. So, this is the geographic equator. It is the great circle on the earth perpendicular to the geographic axis. Now, see, the next one is the magnetic equator. It is the great circle on the earth perpendicular to a magnetic axis. So, see, so this is the magnetic axis. Is it perpendicular to this is the magnetic equator. This is the geographic equator. This is the magnetic equator. Figure al ತೋರಿಸಿದೆ. Now the next term is the geographic meridian. It is a vertical plane which passes through the geographic axis. So ಈ ಜಿಯೋಗ್ರಾಫಿಕ್ ಆಕ್ಸಿಸ್ ಮುಖಾಂತರ ಪಾಸ್ ಆಗಿರುತ್ತೆ ಜಿಯೋಗ್ರಾಫಿಕ್ ಮೆರಿಡಿಯನ್. And finally, the last one is the magnetic meridian. Now, it is a vertical plane which passes through the magnetic axis. So, this is the magnetic axis. ಸೊ ಈ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಆಕ್ಸಿಸ್ಸಿನ ಮುಖಾಂತರ ಪಾಸ್ ಆಗುತ್ತೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೆರಿಡಿಯನ್, ಆ್ಯಂಡ್ ಜಿಯೋಗ್ರಾಫಿಕ್ ಆಕ್ಸಿಸ್ಸಿನ ಮುಖಾಂತರ ಪಾಸ್ ಆಗುತ್ತೆ ಜಿಯೋಗ್ರಾಫಿಕ್ ಮೆರಿಡಿಯನ್. ಸೊ ದೀಸ್ ಆರ್ ದ ಇಂಪಾರ್ಟೆಂಟ್ ಟರ್ಮ್ಸ್ ಯೂಸ್ಡ್ ಇನ್ ದ ಅರ್ತ್ಸ್ ಮ್ಯಾಗ್ನೆಟಿಸಮ್ ಆರ್ ಜಿಯೋಮ್ಯಾಗ್ನೆಟಿಸಮ್. ಸೊ ಥ್ಯಾಂಕ್ ಯು.